Okay, well, let's kind of start taking a look at this stuff here. So the stuff we're going to do today is actually going to be relevant to your lives. I know a lot of times we do stuff and you're like, when am I actually going to use this? Sometimes you won't. Some of the stuff we do is not going to be relevant to a lot of you. This, though, is stuff that will be probably relevant to, I would say, all of you. I would assume all of you because you probably all have money in a bank somewhere. This is all banking stuff, okay? So we're going to go over a couple different formulas here. They're basically the same formula except for one is just an annual one, so it's kind of like the generic. So annual just means like happens every year. And then the other one, we can use it, technically you could also use it for annual, but you can also use it for like semi-annually, quarterly, monthly, that kind of thing. So we'll kind of talk through these. So you may or may not have seen this formula before. It's a pretty common formula, but basically what it is, so it's called the annual compound interest formula. Do you guys know what interest is? Okay, so like if I put money into a bank, so say I go up to Fidelity or whatever and I say, hey, I got 500 bucks and I want to start, a checking account or savings account or whatever. Put that money in there, right? What the bank does is the bank gives me money back for banking with them. Okay, so since I'm trusting my money to them, they give me something back for doing that. So that would be considered the interest. So the interest is money that the bank is giving you on top of the money you already have. Okay, it's kind of like the opposite of a loan. You guys know what loans are? So like if I take out a loan, so like when I bought my truck or whatever, I took out a loan and then I had to, so the bank gave me the money I needed to like finance my truck, but every month or whatever it was, I had to pay them back extra money. So I had to pay them back the $5,000 or whatever I borrowed for my truck, but I also had to pay them extra money because they gave me money. Does that make sense? So like a loan, you pay them, interest they pay you. So it's kind of like a back and forth thing. Now, typically the percentages are higher for loans because that's just the bank has the power in that situation, so they can charge you more than you're going to get back in an interest type thing. There's also different types of interest accounts you can do. Have you guys heard of CDs before? Not CDs that play music, but like CDs in a bank. So CD in a bank stands for certificate of deposit. Basically what that is you put your money in the bank, but there's special rules with it where like you can't withdraw that money for like 5 years or 10 years or something like that. They're called something else too. Savings bonds. Have you guys heard of those? It's kind of the same thing where sometimes like when you're a baby, like grandparents will be like, oh, I went to the bank and got you a savings bond. So what happens is, they pay like $100 for that savings bond or whatever when you're a baby. Then what happens is you leave it in the bank until like you're 18 or whatever the year amount is. Then when you go back to redeem it from the bank, you get more than $100 because you're earning interest over that time. Does that relatively kind of make sense? So there's lots of different things. Like I said, there's just regular savings accounts, there's special ones. The only thing with the special ones, and we'll talk about this in a little bit, say I put money into a CD or whatever, and all of a sudden, my truck crashes and I have to buy a new truck and I need money desperately. I can go and get that money out of that CD, but usually you have to take a penalty. So like if you have something that's like a higher interest rate, typically you have to take a penalty, so they might take some money away from you for pulling that money out early. Is that relatively kind of makes it? Do you talk about any of this in personal finance? Okay, that makes me feel better because I don't know a whole lot about it besides what my mom lectures me about. But that's kind of the general gist. What I do a lot of times is, so I have an account here at Fidelity, but then I also have like a Capital One savings account. So like when I get paid from the school, my money just goes into my Fidelity account, but in that savings account, I get a very, very small interest. I was trying to look it up to see what it actually is, but it's probably like maybe like 1% or less than 1% interest, which is not very good. But I have a Capital One account that I think is 4.5% interest, which is very good. So what I'll do is I'll take my money that goes from my paycheck or whatever from Fidelity, I'll put it in my Capital One account until like I need it or whatever. Then I'll move it back to my Fidelity account. So you can move your money around to try to make a little bit more money. And then there's other things too, like what do you call them? Like when you do like investments, that's a little bit more complicated than this stuff, so we're not going to get too much into that. But that would be like, who's my investment person? Edward Jones. You guys heard of that kind of thing, like retirement accounts and that kind of thing? kind of along the same lines, but again, there's a lot more penalties and a lot more rules with some of that stuff, but that's another way to invest your money and make more money. But we'll just stick with the basic stuff here. So, like I said, we got the annual one and then kind of the general one. Annual, again, is like yearly. The different things we have to know here, so we got that formula. A is always your amount of money that you're getting out of it, so like what the bank's giving you after that many years or that many months or whatever. P is your principal, so principal is always your starting amount, however much money you originally put into the bank. R is your interest rate. Like I said, usually interest rates are pretty small, and you always want to take your interest rate and turn it into a decimal, so you just take whatever your percent is, divide it by 100. And then your T is always your number of time in years, so however many years go by, that would be the T. Like I said, this other formula here is very similar. The only difference is you're taking your interest rate and dividing it by the N, and then you're also taking your time in years and multiplying that by N. The N is the number of times it happens per year. So like I said, like sometimes you have an account that pays you out annually, so like once a year they'll pay you interest. I was just looking at my Capital One account, and they do it monthly. So like every month I get a certain, extra money. I think when I was looking before, I got like $67 for just having my money in my Capital One account. Like they just gave me a free $67 for having my money in there, which is really nice, right? Wouldn't you love to have just $67, whatever. So that's why you put your stuff in savings accounts. But anyway, so they do that monthly. So like for my N here, I would do 12 because it's happening 12 times per year. Does that kind of make sense? Okay, and then like I said, these are just ones. So like monthly, 12 times a year. Quarterly, if you've heard people talk about quarters, quarters are 4 times a year, so like every 3 months. Semi-annually is something that happens twice a year, so every 6 months. And when you do stuff, typically the bank is going to round down. So like say you get some sort of decimal that's like 5.97 or something like that, they're going to take that 7 and they're actually going to round it down and keep it at that 9, just because banks are in the business of making money, so they're going to always round down even if the number typically would round up. So if we get to any of those, I'll kind of show you that. Okay, let's actually do an example here. Everybody still got their packets from before break? Okay. So it says, suppose here we got $1,000 deposited in an account that pays an interest rate of 3.5%. I would say 3.5% is pretty good. How much will be earned in the first year if the interest is compounded as indicated below? Okay, so the first one just wants us to do it annually. So again, annually is basically it happens one time a year. So whether they do that in December or January or whenever they do that, annually is once a year. So we're going to take that formula we had from the previous page. So we're looking for our amount that we're going to get kicked out of the bank. Our P is our principal, which is our starting amount, which is the $1,000. In parentheses, it's going to be 1 plus. What the 1 stands for is the money that we already have in the account. So like if I took 1,000 times just the 1, I should get $1,000 back, right? Because they're not, if I invest money in the bank, they're not taking it away from me, okay? If it was a loan, it would be different, but when we're investing with them, they give us money. So that's what that 1 is. And then the number behind that is our interest rate. So here it's 3.5%. What you want to do is you want to take that value and you want to divide it by 100. Dividing it by 100 is the same as moving our decimal. I don't know why I wrote it small there. 0.035. It's the same as moving our decimal to the left 2 spaces. So it would be point, and then a 0 would go in there as like a filler. So 0.035. That's going to go in there as our interest rate. Close our parentheses, and then it's going to be to the power of our number of years. In this case, I think we're just doing it for a year. Yeah, the first year. So if it's just the first year, it'd just be to the power of 1. So then there you would just kind of start by solving this out. So just making sure you're following order of operations where we start inside the parentheses, right? So we would add that together first. So it'd be like 1.035 to the first power times 1,000. Next would be our power. If something's to the power of 1, doesn't it just stay as that number? Should, right? And then we would just take that 1,000 times that number there. So 1,000 times 1.035 would be 1,035. And we know that would be in dollars, right? So what this value is, this is the total value that's in our bank account. In our question here, it asks us how much interest we're making off of that. What part of this is the interest? So interest is the extra the bank is giving us. No, well, yes, but what did that result in here? Like, what part of this kicked out this? How much did we have in the bank originally? $1,000, right? Now in the bank we have 1,035. How much did the bank give us? 35, right? So basically what you do is you take your current amount there, that 1,035, minus your original amount you put in the bank, and that kicks you out, be 35 in this case. That's how much you're actually making in just interest. So like that's the extra money the bank is giving us. So if they say, hey, find the total, this would be our account total. So maybe you want to like write a little label there. That's account total. That, the 35, is just the interest that you're making. So pending what they ask, just be careful on that. Okay, so that's us doing it annually. We just get money out of the bank once. Another option we have here is semi-annually. So maybe you go to the bank and they're like, well, we offer this annual plan, but we also offer this semi-annual plan. So semi-annual happens twice a year, so we're going to use that other formula. So our original stuff is kind of the same here. So we're looking for our account total there. Still putting that $1,000 in the bank. In our parentheses, the 1 stays the same, because that's, again, just, it'll kick out this 1,000 number because we're not losing that 1,000. But now when we do our percentage, you're still using that 0.035, but you're splitting that 0.035 up into 2 different times that we're doing this. So you're going to take that and you're going to divide it by 2 because this happens twice a year, okay? So then we close our parentheses, and then the power is also going to change because we're doing it twice a year. You just take however many times you're doing it that year, the 2, times how many years you're doing it. And again, we're just looking at this for 1 year. Okay, and then we'll calculate that out. So here, again, most of the stuff's the same here. I would start inside my parentheses and divide this out first. So I would take that 0.035 and divide that by 2, which gives me 0.0175. And I'm going to skip a step here. If I add 1 to that, wouldn't that just make that 1.07 or 0.175? Drop my other stuff down there. Again, kind of combine another step here. If this is 2 to the first power, isn't that, or not 2 to the first power, 2 times 1 for our power, wouldn't that just be the same as to the power of 2? Yeah. So then from there, you can either type this all in at once, and it should pick up order of operations for you. So like if I typed in 1,000, parentheses, 1.0175 to the power of 2, that should kick out my answer. If you're not typing it all in at once, make sure you do your squaring first, then times 1,000, because if you take this times 1,000 first and then square it, you're going to get a huge number, and that's not what we want, okay? So do your squaring first, then take that times 1,000. So then that kicks out 1,035.30. Again, when we're working with banks, so we'll go out to 2 decimals, because that's, you know, what dollar amounts are in with cents. But if this is 0.306, a bank, if they're paying us money out, they're actually going to round this down, so it's actually going to be 30 cents. Does that make sense? So typically we would round that up to 31. The bank's not going to allow us to do that. They're going to keep that 625 or whatever. So we are going to round this down. So it'd be 1,035.30. And again, we just round that down because banks are like that. And then again, to find our true, like, you know, interest that we're making, we would just do our $1,000 or our $1,035.30 minus our $1,000, and that would kick us out $35.30. So in the big scheme of things, it's like, okay, well, you're making an extra 30 cents. But if you're putting hundreds of $1,000s in the bank, or, you know, more than $1,000, which to you guys $1,000 seems like a lot of money, $1,000 is not a lot of money. When you put lots of money in there, that 30 cents means a lot more, okay? Because that would go up quite a bit. So it seems like it's not a big difference, but this is still a better deal than the other one, okay? And then the last one they have here for us is quarterly. So quarterly happens how many times a year? 4 times a year. So it's the same formula. So our account total is equal to our 1,000 we're putting in the bank, times 1 plus, and then again we keep that same decimal for the top for our percentage, but this time it's happening quarterly, so we're going to split that up to happening 4 times a year. and then we do that to the power of 4, because we're doing it it's going to be compounded 4 times a year, times we're just doing it over 1 year. And then you just do the same thing, so you'd have your 1,000 out front there, 1, and then again I'm just going to divide that out, so 0.035 divided by 4 gives me 0.00875, and then again 4 times 1 would make that 4. And then again, I'm just going to type that in one shot. So I'm going to go 1,000, parentheses, 1.00875. And you wouldn't want to round on something like this, because if you're rounding, that's going to take money away from you. Okay, so you don't want to round in a case like this. You want to leave it exactly as it is there. And then to the power of 4. So this one is going to kick out, should be approximately, this one should also probably be approximately. So approximately 1,035 point. And then this one is 462. The 2 would round down either way, so 0.46. And then again, to get your actual interest that you're making, 1,035.46 minus your original $1,000 you put in there, $35.46, which again doesn't seem like it's a lot more than 35, but if you're putting $50,000 in the bank, that 46 cents is going to be a lot bigger number. Okay. Okay. A couple more things to write here, and then we'll finish off our examples. So jot those guys down, and then we'll talk through that. Okay, so let's take a look at this next stuff here. Um, so we talked about, semi-annually, quarterly, that kind of thing. Most banks are going to do compounding daily. So pending the bank or pending the situation, sometimes they use 365 for what they use to do their calculations for, like the every day of the year. Sometimes they use 360. If they're using 360, what they're doing is they're splitting that up a little bit more consistently for the months. So like they're taking the 12 months and doing 360 divided by 12 is 30. So they're just considering that each day would have, or each month would have 30 days, which we know is not true for all months. But that's their way of keeping it consistent per month. Compounding daily is probably your best bet because if you have money in the bank or whatever and you only leave it in there for a month, if your money's only in there for a month, are you getting that annual interest rate if you didn't leave it in there a full year? No, and you're not getting that quarterly interest rate either because that'd have to be 3 months. So if your money's going in and out, the compounding daily is a better situation for you because your money is fluctuating day to day. Next thing there is APY. You may have heard of this before. They have this a lot of times on like commercials. There's say like APY financing or something like that when they're trying to sell you something that's expensive. What that stands for is annual percent yield. What you're using this APY for is to compare two different offers and see which is the better of the two offers. Okay, so whether it's monthly or weekly or quarterly or whatever, comparing that to some other type of financing plan to see which of those is a better deal. Okay, so that's just the generic way of comparing. So that's what our next example is going to be. So look at that one. So it says, what is the APY? So again, annual percent yield. For 4.5 interest rate compounded semi-annually, so twice a year, and then daily, so every day. And what we're going to do is we're going to use $1 as our principal for a couple reasons. One, to keep it consistent for both of our plans here, and then also if we're using $1, it makes the math really easy because one-time stuff is easy calculations. So that's typically what you want to use here. So if we're doing this semi-annually, so again we're looking to kick out our account balance. Our principal we're using is that $1, and again, we're just using $1 because that makes it easy math. And then we do our same stuff we did before, so 1 plus, in this case, our interest rate is 4.5%, so we divide that by 100, or go over to the left 2 decimal places, which would make that percent 0.045. First one we're looking at here is happening semi-annually, so that means it's happening twice a year. And then that would be to the power of 2, again, because it's happening twice a year, times our number of years. And again, we're just doing this as an annual thing, so we're just doing it for 1 year there. Okay, then we just do our calculations out. So we'd have like 1 times, this divided out is 0.0225. So it would be like 1.0225 to the power of, again, 2 times 1 is 2. Then from there, I would just take that and square it, and then take it times 1. And again, it's nice because 1 is easy to do the math with. That should kick out 1.0455. And then again, to figure out how much extra money we're actually making there, we would take and we would subtract. So we would do our one that we just kicked out there, the 1.0455, minus our $1 we put in there originally. And that would kick out 0.0455. So that would technically be like the amount of money we're earning if we put $1 in there. But what we want to do is we want to compare this. So this is actually going to stand for our APY number that we're trying to calculate out. What we're going to do is we're going to turn this back into a percentage because our APY is a percent. So you're going to take that value there that you got, and you're going to take it times 100. And when you take it times 100, again, you just go over 2 decimal places to the right. So that would be like 4.55%. So originally it says, that you're 4.5%, but if they're compounding that semi-annually, you're actually a little bit higher than that. Okay, so then what we're going to do is we're going to take that one and we're going to compare that to if it was compounded daily and see what that APY kicks out. So here for daily, they want us to use 360 days per year. So again, our formula is going to be similar. A is equal to, again, we're just using 1 as the principal to keep it simple and keep it consistent. And then we'll go 1 plus, that decimal number for our top is still the same, the 0.045. This time, though, we're compounding this daily, and they want us to use 360 for that. So we divide it by 360 to the power of, and then it's going to be to the power of 360 times our 1 year. Then you just do the same thing where I would simplify this stuff inside parentheses there and divide that out first. Of course, that shuts off. So it'd be like 1 out front, and then 1 point. When I divide this out, I get 0, 0, 0, 1, 2, 5. And then 360 times 1 would just be 360. Then again, I just take that number to the power of 360 and then take it times 1. So that's going to kick me out 1.0460. And then again, we want to take that value minus our $1 we originally put in there. That kicks out the 0.060. Then again, we take that value times 100, which would just be going over 2 places to the right, which would give us 4.60 for our percent for our APY. This one's APY as well. So looking at that, that's a slightly better deal than our other one because 0.6 would be a little bit more than 0.55. Okay, let's see if we can sneak this last one in here before the bell rings. Good if I flip? Okay, I'll scan it too and put it up. Okay, let's get this last one hammered out though. Okay, so this one says a bond paying 7% interest rate compounded annually has matured after 8 years, giving the owner $10,000. How much was invested 8 years ago? Okay, so this one's a little different because we're working it backwards. So they tell us how much money was kicked out. We have to figure out how much money we originally put in. So what you want to do instead of A here, we're going to put that $10,000 in there because that's how much got kicked out after our 8 years. We don't know what our principal is because that's what we're trying to find. In our parentheses, it would be 1 plus. Our percentage there is 7%, which is a really good percentage. So that would be like 0.07 over, and I guess we don't have to do it over anything. I could put it over 1 there, but I don't really need that over 1 because it's annually. And then it's kept in the bank for 8 years. So then I would just multiply, or not multiply, I would add these two together. So it would be like P times 1.07 to the power of 8 is equal to our 10,000. And then what I'm going to do, since this is probably a gross number, is I'm going to just divide by that chunk there because I need to get the P by itself and its multiply. So to get rid of that 1.07 to the 8th, I'm just going to divide by that on both sides. And you get 5,820 and 9 cents for your principal. All right, that's it. Sorry I talked so much and wasted our time. But that's it.